So there's also another way to do alignments. Again, there's many ways. Well, we can also do it by just taking one particular sequence and then finding relationships that way. So basically, I just have here, I took the chimpanzee um, sequence of amino acids, and all I did was this. I took it and I threw it into BLAST P, and then what I'm choosing here is this thing here called PSI-BLAST. That's position-specific iterated blast, and that is pretty cool. And the reason that's cool is that it specifically allows you to do a blast with position-specific scoring. And the reason you would do that would be to find some sort of evolutionary relationship, usually distant, and you can modify all kinds of stuff with it. So that's why I chose that. So I'm just going to hit blast, and then again I'm going to pause the video because this will probably take a minute or two. All right, I'm glad I waited because it took about a minute or two. So what do we got here? So let's take a look. And what we see is kind of what we'd expect. Now remember, we put in a chimpanzee sequence. So it makes sense that, we would expect the Homo sapiens to be the closest. But let's just kind of on purpose, let's grab Homo sapien and gorilla. Let's grab a mutant Homo sapien. And then let's start grabbing some things a little farther down the tree that are not human. And some of I don't even know what that thing is. We're just going to grab that. And then we'll go down and grab a few more that are non-human as well. Let's see. Here we'll just grab, I don't even know what that is. And let's really jam down the list and grab some stuff. You can see here what's happening to my my percent identities as I go down here. And then, is that a horse? That's probably a horse. So, and then I'll go the very, very, very far down here and see if we'll just grab whatever that thing is. Okay. So now we have all these things. And let's see, you can see I just kind of selected certain ones. And so there's a bunch of stuff I can do from that. I can do alignments, which we've done, but let's do distance tree of results and see what we get here. So as you can see, here's yet another way to do a multiple alignment. And this one does not have the actual scoring there, but you can do all kinds of stuff to it. You can manipulate. But if you see here, this makes sense. So there's our chimpanzee. All right, and of course we have our Homo sapien really close to it. Then we have the mutant Homo sapien a little bit farther out, followed by the gorilla, which makes sense, and then all these other organisms, which I don't even know what they are, except that's probably some kind of horse. And way over here is the Octodon dagus. I don't know. I have no idea. Let me pause the video and see what the heck that is. Well, that thing is actually a little rodent, so that's pretty cool. And so that is another way we can use a tree through NCBI BLAST. But there's other things we can also do as well. If we click on multiple alignment from here, we're going to get something like this, and hopefully this shouldn't take too long. This is good. So here we see something that gives us kind of our multiple alignment, and again we can zoom in and we can zoom out. We can go as specific as the amino acid. But you can see here that I like this as well because there's definitely distances to it, so we can kind of see, well, what's this little weird thing in here? Let's highlight that, and we can see there's a serine there that's not in the other ones, which is kind of cool. And we can come back out and do all kinds of stuff, or we can move left and right. So this is another great tool to be able to kind of look for certain areas of difference or not. It also allows us to find areas of similarity, which there seems to be a lot here, and there looks definitely to be a lot of difference in this area. Let's see what's going on there. So we do have obviously variability in a lot of these things, and I like also how it puts the name there so you can kind of see the relative distance. There's a lot more that this can do. Here is another view of what we're seeing here. So that's just a quick kind of overview to show you how you can do multiple alignments using NCBI as well.